Okay, welcome back to my programming in ARM assembly video series. And in this video series, I'm trying to create a simple ASCII to integer conversion function. This is a function that I already created in my number guessing game video series, but I wanted to come back to it and make it just kind of a standalone video. The idea is I want to build up like a tool chest of individual functions that I can refer back to in future programs. All right, so let's go ahead and jump back into it. So in the first video, I just kind of laid the foundational framework of the three files that we're going to be working with, and then I explained the outline of the plan to put all this together. So let's get back into the code. All right, so the first thing I want to do is I need to have a value in register 1 that we're going to convert using our A to I function. So that means we're going to need a data section here. So let's create a prompt to give the user a prompt of some kind. And we'll be using the ASCII's value type for that because we're going to utilize our print function that we've already built in a separate video. And I'm going to say just simply type a number, and then we'll do a colon and a space and no carriage return. That way when the prompt comes out, it will just end right there and they can type the number in immediately after the colon. And then we're going to need some kind of an input prompt or input buffer. So I'm going to create this input here. And like I was saying in the first video, I created like a cheat sheet of sorts for myself so that when I'm doing certain things, I can just refer to my little handy guide over here so I don't have to try to look all these things up each time. So in order to have an input, I'm going to use the type ds.b, and there's links down here if you're not familiar with some of these different directives or some of these other values. You can look this up on sourceware.org. It's just following those links. So for type ds.b, we need some kind of input size and then a fill value. Technically, if you don't include the fill value, it will default to 0. And that's actually what I want anyway. I want it to be 0. So I'm just going to go ahead and type in 0 there just so there's no mystery about it. But again, if you don't include that, it's just going to default to 0. Now we haven't defined what we mean by input size here. So let me come down here below the global directive, and I'm going to add in like this equality statement. And I'm going to put input size, and then we need to populate this with the number of bytes. So this is how many characters that we want to accept from the user when they're typing in their number. Now a number could potentially be up to 10 character. A 32-bit number can potentially be up to 10 characters, and also an 11th character if we include the negative symbol. So we want to include at least that many, but we also need to leave room for a carriage return and a null byte. So I'm just going to say 20 characters. That will be more than enough to handle all of the input plus plus the carriage return and the null byte. All right, so we have that, and then we'll come down here into our start section, and I'm going to present the user with the prompt. So in order to do that, again, I'm going to utilize the print function that I made in a previous video. So I'm going to load into register R1 the memory address of our prompt, and then I'm going to branch and link to that print function. And what that print function is going to do, it's going to go through this prompt. It's going to count up those characters so that we don't have to do that manually. And then it's just going to put that prompt out onto the screen for the user. In fact, I think we're good to stop here, and we can even test it just to make sure that we are in fact getting that prompt, because I don't want to do too many things at once without testing. So let's go ahead and write that out. Let's quit. Let me just clear out the screen. Let's make our code, see if we have any errors. We don't. So let's run the main. And yeah, you can see, we got type a number, colon, and then it just waits right there for the input. Otherwise, if we put in a carriage return, it's going to say type a number, and then they're going to end up typing it here underneath of the T, which I just think looks weird. All right, let's go back into the main, and let's set up the handler. Now that we've got the prompt out there, let's set up the handler for actually taking that input and storing it. And again, I'll refer to my reference over here. So in order to store that value, I'm following what the system call reference guide has pointed out. but I've converted it into a format that's a bit easier for me to follow along with. So we need to move into register 0, the immediate value of the immediate value of standard in, which is just 0. And normally I would go ahead and define standard in up here in the equality section. So let's go ahead and do that. And then I'll go back up there in a moment and define what that means. And then we're going to load into register 1 the input prompt, the memory address of the input prompt. And then we need to move into register 2 the size of that input, which I've defined as 20. So we will say input size like that, which has already been declared up at the top. And then finally we need to move into register 7 the immediate value of 3, which is read. After that we need to do a service call for service call, so I'll just go ahead and put that here as well. So let's define what some of these other things mean. So by service call, when the assembler sees that word service call, it's going to replace it with the number 0. And when the assembler sees that word stdin, we want it to replace standard in also with the number 0. And when it sees the word read, read, we want it to replace that with the value 3. All right, so here we're getting the input from the user. Currently we're not doing anything with it, but let's just make sure that we have correctly set up this the steps necessary to actually make the prompt stop and take input. So let's write that out. Let's quit. Let's make our code and let's run it. All right, so type a number, and then this is where we could type, 456 or whatever number we want, negative 239 as an example. All right, so now that we are getting that number, we need to call into the A2I function and do something with it. But we haven't made the A2I function yet, so let's go ahead and work on that. And like I pointed out in the first video, I've laid out a roadmap for myself, so that will just make things a bit quicker. So let's go ahead and just kind of follow that roadmap. In fact, that roadmap is almost copy-pastable. Not quite, but pretty close. So the first thing we want to do is we want to make sure that anybody using this function, my future self, knows what this function needs as its input. So I'm going to put that up here at the very top. And I'm going to say the input is that R1 must contain the memory address of the string we want to convert. And that's probably good enough for that. And then I'm going to say that the output is that R1 will contain the converted value. Okay. And then when we get into the actual A2I label here, we want to save and initialize our registers. So we want to push onto the stack R0, and then I'm going to say probably R2 through R7. I don't want to push and plus the link register. I don't want to push R1 onto the stack. Actually, it doesn't matter if I push it on the stack, but I don't want to pop R1 off the stack because R1 is going to contain the output value. And if I push R1 onto the stack and then pop it off afterwards, we will lose the information. So that's the first thing we'll do is we'll push those registers onto the stack so that they get saved. And then we need to do our variable initialization. So I'm going to move into register 2, the immediate value of 0, and then that is that's going to hold our number as we're working on it. And then we want to move into register 3, a power of 10, the immediate value 10. And again, that's because when we're doing certain operations like multiply and divide, we can't actually put that immediate value of 10 in the multiply instruction. So we need to have that inside of a register. And then I'm going to move into register 4, the immediate value of 1, and that's going to keep track of that positive or negative. All right, and then we're going to drop down here, and the first thing that we want to do is we want to say, is this number a negative number? Did they include that negative, like the minus sign? So I'm going to load into register 0 the first byte from register 1, and then I'm going to advance the pointer forward by 1. Actually, I wonder if I even have to. That's interesting. It may be beneficial not to do that. It just now occurred to me that I might not want to do that. But we'll stick with the roadmap for now. So we want to compare the byte that we just pulled off, which is now stored in register 0, with the immediate value of the negative sign. And I want to say if. So I'm going to say move equal. So if the equal flag was just set, I want to move into register 4 the immediate value of -1. So in other words, I'm updating register 4. And if it's not the case, so if it's not equal, if the equal sign was not set, then I want to say sub not equal. So subtract if that was not equal. Only do this if that comparator was not true. And I want to take the register 1 and back it up by 1 byte. And kind of what I was thinking here, in this particular case, it might be useful to actually put that at 0, but I've never experimented with that, so I'm not going to do that now. But it's now that I think about it, it wouldn't be worth it, because if it turned out that it was negative, then we would have to move the byte forward. So it's kind of 6 on one side, half a dozen on the other. All right, now once we have done that, we need to move into our loop section. And this is where we're now going to just loop through each byte and determine what each number was. All right, so we want to load into register 0 the next byte from register 1, and then I want to advance the pointer forward by 1. And then we have to compare, I believe. Actually, the next thing we want to do is subtract from register 0 the immediate value of 0, which doing that is the same thing as saying that. But a lot of times, this just makes it more clear as to what we're doing here. We're trying to find the ASCII value, or we're trying to find the integer value from an ASCII number. All right, so once we subtract off that value 48, now we want to compare register 0 and to the immediate value 0, because we're looking to determine if we end up with a negative number. If we ended up with a negative number, it means that we've reached the end of the input and we need to do something else. So I want to say, if R0 was less than 0, so branch if less than, and we'll branch to some label that I'm just going to call future for now because I don't know what I want to call it. If we did not, if the result of that operation was not less than 0, then we want to multiply and add. And the way we'll do this is we're going to say we want to take R2, which the first time we go through this will be 0, and I want to say that R2 is equal to R3, which is 10, times R2, which the first time we go through is 0, so 10 times 0 will be 0, plus the value that we just pulled out, which is R0. So the first time we go, if the number is 456, the first time we come through this, we will end up with 4 in register 2. The second time we go through it, we'll end up with 45 in register 2. And the third time we go through it, we'll end up with the number 456. And of course, if the number was larger, it would keep getting incremented by a power of 10 each time we go through the loop. Okay, so now and then of course, once we've reached down here, we want to branch back to the top of the loop, because the exit point will be this part right here. Once we reach the end of the, we will branch to this future label. So let's figure out what I want to call this. So essentially, We could just branch straight to the exit, but I want to branch to another part that I'm going to call update registers. Seems valid. And then we'll come down here and we'll create this update registers label. And this is the part where I want to say we want to multiply register 2 times whatever value is in register 4, and then times register 2. So register 2 equals register 4 times register 2. So if register 2 is, let's say, 456, and register 4 is 1, then register 2 will just be 456. But if register 4 is -1, then we're saying register 2 will be equal, at the end of this multiplication, will be equal to -456. And then the next thing I want to do is keep our promise, which was that when we are exiting out of this program, when we're done, we want to make sure that register 1 contains the final value. So register 2 at this point contains the final value after our loop and after our multiplication operation. And then we're just wanting to move that value into register 1. And then finally, when we exit, we want to pop off the stack all the registers we've touched except for register 1. And I said R2 through R7, but it looks like all we've done here is R2 through R4. So we'll go ahead and do that, plus the link register. And then we will branch and exchange to the link register, to the memory address contained in the link register. So let me update that to register 4. And I think that's our function. If I didn't make any mistakes, which it's almost guaranteed I made a mistake somewhere. But if I didn't, then it's just going to work immediately, which would be wonderful. But let's quit out. Let's write our code. Let's quit. Let's make and see what kind of errors we have. Of course we have something. Multiply and add has an error in there, so let me check that. Oh, I think I see what I did. Down at the bottom, yeah, here I didn't mean to use multiply and add. I meant to just use the regular multiply instruction. Here I wanted to use multiply and add, but here I just wanted the regular multiply. So let me write that out. Let's quit. Let's make clean. Let me clear all this out, and now make. All right, I mean, if that was our only mistake, that's pretty good. So let's run our code. And let's say a number like 345, and it seems to have ran and didn't segfault and didn't come back and didn't get stuck in an infinite loop or anything like that. So I can't be sure that the code worked. So what we'll do, I'll go ahead and save everything just like it is here. And then when we come back in the next part, we'll step through, perhaps look at the debugger and make sure that the value 345 is actually getting stored in register 1 as an integer. If you made it all the way to the end of the video, thank you so much for watching, and I'll see you in the next part.